So my name is Jake Saunders. I'm based in Singapore. I've been with the company now for about 10 years. In that time, I've focused on carrier strategy. More recently, moving more focus onto IoT. Particularly done a number of projects looking at a number of individual countries for secure IoT developments in India, as well as Thailand and so forth. So exciting opportunity. If you now could just introduce yourself.
Hello, everyone. My name is Eric Hui. I'm the treasurer and the executive committee of Asia Cloud Computing Association. The association is a industry kind of a group which provides and advocates the use of cloud computing technologies in Asia Pacific. I also have a full-time role with Equinix. It is a network-dense, cloud provider-dense data center colocation company.
Hi, ladies and gentlemen. I'm Jonathan. I am the Vice President of Unabiz Network, Singapore. We are the Sigfox network operator in Singapore and Taiwan. So we also have a booth up there. Please feel free to come down and take a look. I'll discuss a bit more later. Thank you.
Hello, everyone. My name is Yang Yang. I'm working for Chinese Academy of Science. I'm located in Shanghai. I'm the director for the first wireless sensor network and communication laboratory in the Chinese Academy of Science. The most impressive project we have done is to develop the IoT monitoring system for the south to north water diversion system. It's 104,000 kilometers long, involves more than 100,000 sensors from 130 vendors. So it's a very challenging task. We have done this in the last 4 years. In addition, I'm the director for the OpenFog Consortium, Great China region. So OpenFog is focusing on providing the on-demand computing service for Internet of Things applications. Thank you.
Very good. I think we'll do is, you see both microphones. So we've got essentially about 45 minutes or so to cover a range of topics. It's an exciting event. I think in terms of what we'll start off with initially is we've seen essentially 2015, 2016, 2017. I mean, M2M has been fairly successful in terms of growing, in terms of shipment numbers. But from about sort of 2019 onwards, we see a huge growth in terms of IoT deployments in the unlicensed as well as licensed bands. In terms of what do you see as the main critical factors that primes the growth? So we've seen okay growth now, but really it takes off from essentially under a sort of 100 million modules to potentially by 2025, almost 1 billion units on an annual basis. What do you see as the opportunities that are driving that?
Okay, I'll start with what I observed over the last few years. So in the last few years, a lot of the IoT deployments using a lot of the mobile carriers, cellular technology, has been fueling a lot of investments, especially in private infrastructures. But the emergence of cloud providers, I think, pretty much just changed the gamut so that a lot of the what I called mid-enterprises to small and medium business can have a taste of also IoT usage and application models. So with the advent of a lot of new of these cloud providers also emerging themselves into specific IoT products, that actually opened a lot more viewpoints of applications developments on top for IoT. So if I have to group it in two different categories, one thing is the connectivity models have changed significantly, and now with the emergence of low power WAN. And then the other is just the applications possible for IoTs have become much more varied. And I think that helps a lot. And potentially, this will go even further as we go along the road.
Hi, maybe I share something. IoT is a revolution right now, all right? In my career, I went through back in 1997, the e-commerce and the mobile revolution. That time it was revolution, today is status quo. I went to the smart city revolution back in 2003, we start talking about it. Then the broadband in 2007. Today is 2017, we're talking about IoT. One big difference is that I think IoT is a lot more complex than the other two revolutions. All right. Two things. What are the two things I feel is a big obstacles in IoT? I'm pushing it on a daily basis in my job today, but there are two big things. Number one, network. Can you tell me one single network that works for IoT? Anybody? None. Why? But there are different networks for different applications. All right. So for the longest time, people have been using 3G. It works for a lot of things. Use Wi-Fi. It works for a lot of things. But different networks serve different purposes. Right? So on top of that, in recent years, LPWAN came aboard. Low power wide area network. And that's where we are playing. All right. We are providing Sigfox network. So there is another new networks out there. So is Sigfox, am I here? I'm not here as a salesman to tell you, oh, Sigfox network can solve all your problems. No, it's not. Different network solve different purpose. But what I'm trying to say is that from a LPWAN standpoint, the Sigfox network, and maybe other MBIoT and so forth, is going to offer us another new dimension for a lot more use cases that was never before possible. And this is one more network that actually can help us drive towards the 100 million or the 1 million devices out there. All right. The current available network today, none of them by itself can cater to all of this. So you have this complexity of a very diverse, different kind of networks out there. The other problem is ecosystem. I always use this example that I tell this story several times. Back in 2004, I remember, I was in one of the polytechnics discussing with the lecturers or the research body there, what are the next big thing we're going to do? What are the new ideas we're going to do? And one of the programs they thought we will do at that time is that maybe we should create a portal to list out all the students up there. Because when I graduated in 1992, I realized I lost all my friends because everybody changed handphone, their email is gone, I don't know who they are. It takes time to get them back. So I thought a portal would be nice. And do you know that 2004 was also the same year that this man who was drunk and heartbroken and alone, he wrote a software, and that software became a multi-billion software called Facebook. All right, it's called Facebook. But you can do that in Facebook. Can you do it in IoT today? I don't think so. All right. Why? Because Facebook is a single-dimensional skill software. Of course, there are many elements that make it successful. But IoT, you have hardware, you have devices, you have platform, you have networks, and you have a whole lot of applications. It is multidisciplinary. So to bring them all together, but customers don't buy network, customers don't buy devices, customers don't buy a platform, customer buys a solution that solves their problem. So creating that solution, it means you need to tie up all of them. And today there are many, many different devices, platform, hardware, software. To tie them up, it is a challenge. So but the thing is, now we are at the beginning of a revolution. All right, it's back like in the cowboy days of the gold mine, where things is messy. But I believe platform like this is good. That people start to talk to each other, devices, solutions start mixing, and then that is where we create new solutions for end customers. So I believe the year to come, we're going to see big, big stuff coming. Right.
Good. Professor Yang?
Yeah. In addition to Jonathan's comments, I would like to add two more things. Yeah, we have a new member. Okay. Hi. Return to 2006 or 7, when we started to do wireless sensor networks at that time. We found a lot of technologies here and there, but it's very difficult or nightmare to integrate them together. So at that time, the key challenges are two. The first one is standardization, and the second one is the price. So when we talk to many different vertical industries that want the idea of smart city or wireless sensor network solutions, but when we come to the price, it will be very, very expensive. So I think now, today, we have partially solved the two problems. As Jonathan mentioned, since the ecosystem is built, so the price or the challenge for integrate different technologies together is much lower. So we are at the point that we can talk to more and more vertical industry leaders that we can improve their productivity by implement IoT solutions. The second good news is that we have a good standard. So we gradually we come to several set of standards, so more and more small companies can work on and develop their own devices. So that's make the ecosystem more efficient and also the price down. So that's my observation. Thank you.
Thank you, Alan. Thank you, Professor Yang. So we've got a late arrival, Alan Tait. Don't worry. Myself, I almost didn't make this panel as well. I was told to go to session 3 when it's meant to be session 1. So perhaps just do a quick introduction on who you are and who you represent.
Yeah, absolutely. So, as I said, apologies for being late. My name's Alan Tait. I'm Stream Technology's Chief Technology Officer. Stream are a IoT connectivity company providing management services for connected devices worldwide.
Very good. So maybe to my next question, I want to put this up front because I think it's a key issue, is in terms of, we've got a number of very lovely, great technical solutions, be it sort of Sigfox, or we've got Cat 1 or Cat 0, M. The communication solutions are great. The modules are coming down in price, but clearly that's not the whole story in terms of getting those integrated into final products, integrated into different enterprise systems. The system integrator, I think, plays a very important part of this process. Do you think that is straightforward enough? Is that easily implemented, given the needs for security and so forth? Perhaps, Alan, do you want to start?
Yeah, absolutely. I mean, from my point of view and from Stream's point of view, not yet. It's very much, there's a lot of fragmentation still existing in the particular M2M and IoT markets. One of the key challenges around it is, as you're saying, a unified security model. That doesn't yet exist. And a lot of the hardware is subtly different, and the communications protocols are different in many different ways. So what we are seeing at the moment is, while IoT is on the ascendancy, that there's not yet really any unified standard. So there's all the different low-power radio ones. There's the carrier-backed 3GPP, NB-IoT applications. There's still very much the cellular ones that are pushing forward. But what we're beginning to see is that a lot of customers are beginning to look at it from a more data point of view. So the device becomes abstracted and less important. And from that, then you can place your security on the device and then on the cloud as well, and do a secure connection between the two. So it's about abstracting that hardware layer away. So as you say, the communications technology isn't as important.
Perhaps Jonathan, you want to contribute?
Yeah. Okay, the uniqueness of Sigfox is, if I may just quickly recap, so if you're not sure, is that there are 4 things. Number 1, it is low power. So low that a transceiver can last 5-10 years. So when you put a device up there, it probably can last up to almost 5 years. Which means, and why is this important? It means that you don't need to lay a power cable, or if you put you put a battery that you don't have to replace it for the next 5 years. And why is this important? Imagine if you were to deploy 1 million or 100,000 sensors out there. If every 2 weeks you had to go and change a battery, it's going to go crazy. If you have to lay a power for 200,000 devices out there, it's going to be crazy. But if you want to, Sigfox enable us to do that easily without power. All right. Number 2, it is long range, which means we are ready right now as we speak today in Singapore. We got a license just November last year. We started deploying the network. And within 4 months, we covered 95% of outdoor coverage in Singapore. All right, and the first building, in fact, one of the first networks, Allocation building, one of our partners is there on the floor. All right, so it is out there already. You can use it, and you don't have to. And soon, right now, we have 32 countries deploying, and soon 60 countries by next year. So it's one global network. 3. Sigfox is also easy to deploy. In other words, there's no SIM card and so forth, so it's seamless. So you drop the device, it works. Lastly, the cost. What is the cost of Sigfox network? You mentioned about low cost. The cost has dropped so much. If you listen to just now the keynote speaker by the first speaker, Charles Reed Anderson, he called it the race to the bottom, the race to zero. A Sigfox connectivity today in Singapore, we launched it between $1 per device per year to $12, $1 to $12 per device per year. So in other words, if you look at a monthly basis, it can go as low as 10 cents per month per device. So when you put the 4 things together, it means you can actually deploy millions of devices easily. All right, I have customers talking to me. They tell me they are looking at deploying 200,000 sensors or 1 million sensors out there in Singapore. They are looking at this, and they are stretching their head what network to use. I tell them, like, if you get a device today, as early as this afternoon, you can send your guys out there and start putting the devices. Because why? You just plug and play. All right, the network is already there. But however, the ecosystem not quite ready. There are not too many devices out there ready out there. All right. So I have a lot of customers. Every day I have people calling me, what is Sigfox about? Can you tell me? Can you tell me that? Every day I have inquiries. But the thing is, I don't have enough solutions yet. Products. All right, products out there. So because we are in the early stage of the revolutions, so we need to, if the industry guys today, I'm appealing to all of you here. Be bold. Be bold. Singapore is not known to be very bold, but I'm a Singaporean myself. We should be bold. Get out there, create solutions because the demand, people are waiting for it. Because they need that solutions. I have a lot of inquiries, but it's just that we need to create the solutions. And the ecosystem, I feel, still not really mature as yet. All right, there are people making it, but I'm confident. I'm confident. Within a year or two, we're going to see big changes because I think the ecosystem, the industry is waking up to it. Yep.
Right. Final thoughts?
I definitely agree with Jonathan's point about the ecosystem. It's still limited. One thing is, there's great technologies of capturing all the data, but there's also, I see, a little bit of a lack of really customized analytic engines to really analyze and get the business value out of some of the data being transmitted and stored. So I think, that is also something I think is emerging. There are, of course, big providers that provide some analytics engines, but I'm also seeing a lot more interesting, smaller, much more nimble, niche analytic engines that is customized for subverticals, which I think, potentially all these system integrators out there, as fragmented as is right now, that potentially can garner these solutions together to make it worthwhile.
In terms of Professor Yang, I mean, I saw about 3 years ago, I was in China, and at that time, the Chinese government had this big initiative to set up a sort of smart cities plan for the top 20 largest cities in China. I just wondered, so clearly China is really moving ahead with smart cities. Are there any insights you can give us as to what the state of play is in China in terms of smart city development? There's rubbish collection, there's street lighting which turns on dynamically, there's security cameras. What is gaining traction in the Chinese market?
Okay, thank you very much. So in China, in 2009, actually, the then Premier Wen Jiabao visited a branch of our lab in Wuxi and announced this Sense China project. So at that time, it's a very inspiring program in China, and many governments want to make some impact in this domain. So there are many initiatives about smart cities in China cities. But according to my observation, mostly they're driven by the government. So initially, the government will pay the bill because they want to showcase the capability and the potential of wireless sensor network or Internet of Things applications in smart city. So at that time, actually, it's a very difficult approach because the technology and the ecosystem are not ready yet. So it's very painful and expensive to deploy some of those solutions. So gradually, the areas with priority are the security and also the transportation management. They're in the very early stage. They deploy their own customized Internet of Things solution. For example, in Shanghai, the transportation system covered the whole city using different kind of sensors to monitor the vehicles on the road. So if you want to find a vehicle, for example, you type in a yellow Audi car in the surrounding area, that can identify all these vehicles in the neighborhood. So it's a very impressive project, and I think they have developed by themselves the analytical engine to study a specific type of data. So we still see that the service or applications are kind of fragmented. They rely on different vendors and different government agents achieve their own goals. So they're not fully integrated together. So we still have a long way to go. But very recently, as Jonas mentioned, we are pushing to develop a very unique IoT network for the whole city, for the Shanghai city, using a very special spectrum. And we want to integrate different kind of technologies like Sigfox and also LoRa and also NB-IoT on the same platform. We want to attract the existing services and applications to this single platform and to try to integrate them together by using the same interface, the same software, and same standards. But there's still a long way to go. I think the smart city is a beautiful dream, but we will see some applications is deployed, but not as mature as we thought. But it's a good starting point.
Right,
yeah.
right. In terms of Alan, I mean, where are you based?
I'm based in the UK, Scotland primarily.
Scotland.
Yeah.
So maybe just as a counterpoint, I mean, you're seeing what's gaining traction in perhaps the UK market? We perhaps
Well,
come back to Asia.
Yeah, so we're doing a lot of work in both cellular and low power fields, and we're seeing a lot of applications coming up in smart cities around things like social housing, intelligent transport, waste optimization, so collection and refuge, smart street lighting, and other applications which are very geared around saving money and optimizing things. So very similar to what you're saying about a sort of unified application set for a city. They're not quite there yet, but the social housing aspect is one which is really growing quite strong. I know there's 2 or 3 companies on the UKTI stand today which are working in that particular field, and there's elements there that are about it saves cost because you can detect is the heating working correctly, is the house mouldy, is there any structural or is there any environmental damage that can be fixed quite easily. The other one that's very interesting at the moment that we're seeing is obviously the refuge and waste optimization. So you can tell is a bin getting full. And then if anyone knows the traditional computer science problem with the traveling salesman, it's how do you optimize going around and collecting all of that. And again, if you can optimize that, you can save costs and you can save time. So we're primarily seeing these applications which are about cost saving, automation and optimization.
Very good. By the way, I was not given the little application for questions from the floor. I don't know if anyone on the back has such one of the iPads, but otherwise I'm welcome to take questions by the old traditional method of putting your hand up. So I'll keep scanning the floor, and if anyone wishes to put a question to this esteemed panel, then just raise your hand and I'll take your question. So whilst we wait for any questions from the floor, just to follow on, we've had a perspective from China, we've had a perspective from the UK. Singapore, again, I think with Jurong, there's been a major IoT development in Jurong. Are you, Eric or Alan, able to comment on?
Okay. We have a case actually in Australia, especially for the smart metering. And what we have seen is in the state of Victoria is now mandatory for the residential homes to have smart metering. So what happened was they're still using cellular technology in the smart meters. And then they basically, those kind of utility companies are using cloud technologies to basically generate bills and also to do ERP, enterprise resource planning. So what happened is we have seen a lot of these smart meters now connected wirelessly through the cellular network and then aggregates into data centers. And then the data center has some kind of a private infrastructure component inside for some kind of sensitive storage. I think it's pretty much on the customer data which is being stored. But actually, the customer names themselves is on-premise, but the utilization is actually encrypted and sent over to the cloud provider. And then bills are generated on top of that. So I think that's an interesting use case in Australia. We have seen that much on the smart metering as on the electricity, where we're seeing also more on the water side and also the gas side moving towards that direction as well. In Australia, again, Victoria is mandatory, but again, New South Wales and Queensland, they're starting to move also towards this direction. So we're going to see way more deployments in the direction, in the coming years.
Very good. I mean, Sigfox has been clearly very successful. I mean, there's a number of low-powered, wide area access network technologies. Sigfox has really got over 28, I think, countries, and a very substantial, I think, a very substantial number of the chips that's sold in the market as well have been Sigfox-based. There are these other technologies. I just wondered, I'm going to go down the panel, but first, perhaps starting with you, Alan. Clearly, you believe passionately about Sigfox. Why do you believe in the long term it will still be a successful, dominant technology in the marketplace? Yeah.
All right. The reason why you asked me in the long term, because I think Sigfox play in a very unique space. All right. In the telco space, they have NB-IoT, you have Cat-M, and so forth. But all within the 3GPP, so I think something will come out of it eventually, all right? So Singapore, I think most likely NB-IoT, some other countries, something else. LoRa, yes, is probably also being deployed. But Sigfox is unique in that because in terms of the cost and in terms of the bandwidth, it's the lowest. And it's in a league on its own on the lowest. So you have the 3G, you have the 4G, eventually 5G, it will go up, all the way up, as fast as you can. Then, of course, you go downwards, you have NB-IoT, you have LoRa, you have Cat-M, and so forth. But you go downwards. But Sigfox is even lower in terms of cost and in terms of bandwidth. So I think it is a unique one. And moreover, on top of that, is a telco network, which means the user do not have to go and deploy the gateways. So I believe it will be successful in that it's going to be the one to let you do massive IoT, very, very low cost, and very, very easily, because it's occupying that unique space, right? But of course, it will be successful, not because of the network, but because of the solution. If I may just quote the panel speaker this morning, a lot lies in getting the right solutions out there where the end customer will use. Of course, just now everybody talked about the reference sites. I can't talk about reference site in Singapore yet because we just deployed that. We just launched a network like 2-3 weeks ago. But if you tell me, if I was to share the kind of opportunity and the leads that I have, it is in the many tens right now. And if you look at the hot opportunity, if I calculate all the potential connectivity, is in the many millions, all right, even within the next 2 years. But the thing is, interest is high. It's just to get our act together. As I always say, in a lot of things, plan is easy, but execution is tough. Right, we need to get execution out there, and execution means a lot of ecosystem partners need to work together, right? And maybe if I just say, also to just show an example how things are, we develop very, very simple solution like this. This is just a simple Unabiz. It's just a smart buttons. So when you press, it sends a signal out using a Sigfox network. And then you will go to the base station, and from then on, you go to the cloud. All right, so you can use it for food reordering. You can do it for help desk, incident management. You can also do it for stock replenishment, similar. So I press it just now while talking. So you can see it.
You have a request from customer Unabiz G11.
Okay, real life demo.
Real life demo on the Sigfox network, and it's on a public network. That means that it works anywhere in Singapore publicly. All right, so this is a real life network. So we need to get appeal to you. I mean, I believe this room is full of ecosystem. I mean, industry guys. We need to get our act together, deliver solution, work together. All right.
Very good.
Opportunity is there.
Yeah, thank you, Alan. Alan, do you have any perspectives on how the technology front will evolve?
Well, yeah. So I think, that's a fantastic demonstration of Sigfox. One of the use cases, we know IBM quite well in the UK. They carry around a big red button, and you can press it, and it will generate an alert. But that's the sort of use cases where Sigfox is absolutely fantastic for. Your long range, your low data rate, you need to send over a large distance. But as you said, that's the bottom end of the market, and that's one particular use case for IoT. Going up from there, you do have your technologies such as LoRa, that we are a member of the LoRa Alliance, so full disclosure. But that allows you to do a bit more two-way with less range and slightly more power requirements around about the same, and then you're up into the cellular national network kind of rollouts as you need to do. So the way we see it is LoRa can be one of those networks which is very low cost because you can deploy it yourself and then you don't really have to pay anyone for the transit or backhaul across it. NB-IoT will be the national sort of versions of that, which is heavily backed by companies such as Vodafone and Huawei, and they're pushing that out. And we think that as a technology will be one of the ones which is deployed for large national rollouts and large-scale deployments for IoT. Then you've got the other networks which are currently investigating how do they monetize the existing LTE spectrum. So that's where your Cat-M technologies are coming in, your Cat1, your Cat0 for the low rate, and then your Cat-M for messaging. So it's really coming down to there's so much choice for the enterprise today. Now, Stream, our IoTX platform, we support everything. The data itself is what's important to the enterprise. They don't really care about what actually comes through. So we're pushing towards this whole idea of 5G being the next new stack of technologies that will come together. And if you go on Wikipedia and read the general specification for 5G, apparently it's supposed to support sending 1 gigabit per second to 1,000 nodes at the same time supporting 1 kilobit per second to 1 million nodes. So we're moving up to this form of technology where we need to kind of try and get some coalescence between it. And will that be Sigfox? Will that be LoRa? Will that be NB-IoT? I don't know, but each of them has their own specific niche and their own particular use case inside the market. But what the enterprise cares about is how do I connect my device to my platform? And that's the bit that we all should really be focused on. You're absolutely right, the solutions aren't there yet, but they are coming very quickly. And it's about how do you consume that data? So to us, and I think generally to the enterprise out there beyond the connectivity stack, they don't care about the connectivity. They want something that works reliably, cheaply, and gets the data to them.
Very good. Dr. Yang?
Okay. In China, the situation is slightly different because the telecom industry is not that open, so it's not fully a competitive market. And also, as I have mentioned, currently the IoT applications is driven by the government. So for the government bodies and agents, it's more easy to interact with another key players in the telecom industry, like Huawei or China Mobile and China Telecom, etc. As I can see here, now most of the telecom operators in China and also the manufacturers are pushing the NB-IoT forward very quickly. So although the ecosystem is still booming or in the developing stage, but I would like to anticipate that NB-IoT in China will take the leadership in a very short period of time. But in saying that, but we are working with another group of people from the broadcasting industry to work on LoRa and the Sigfox. So I do agree that in the future, maybe there are several technologies or standards satisfy different requirements. But I would say that the telecom industry in China may prefer NB-IoT better than LoRa and the Sigfox.
Okay. Very good. Let's get the last opinion.
I agree with what Alan said, right? It really depends on the use case. I think all these technologies will emerge and basically segment themselves according to applications. Like 5G, what Alan was saying, that we actually expect there will be actually an overlapping of video in information as part of the IoT capture and analytics on top, especially in surveillance and those kind of applications. So that will definitely happen. From a cloud provider standpoint, obviously, they welcome all kind of transmission technologies because at the end, it's just when they reached at their edge location, then they can just process the information and either store, analyze, or basically retrieve. So, from their standpoint, they're definitely okay. We're also seeing, as part of Equinix, that potentially we're seeing a lot of the data points that's being captured once it's stored. There are also some of the cloud providers asking, can we actually bypass internet before they get to them? So there'll be a little bit more of a demand talking about private links to cloud providers as well. So that's the reason a lot of the hyperscalers are also having these offerings, like AWS have Greengrass, and then Azure and IBM's Bluemix and all these companies are looking into also, is there a connectivity option for private links, potentially for IoT users? So that's going to be an interesting game as well.
Okay. Thank you. got about 30 minutes left. Do we have any questions from the floor? So we've got the gentleman in the middle here. If you can state your name and the company you work for, it would be great. Helps with the context.
Yeah, my name is Serwa. I work in a small company called Whitespace. Okay, I have a question related to Spectrum. We understand in Singapore, Sigfox, LoRa, and many other systems like Fujitsu just now shared about their system using 900 MHz frequency. Wisan, that is being used for smart metering in Singapore, also use 900 MHz frequency. And in Singapore, there are only 5 MHz available, 920 to 925, 5 MHz of frequency available. Now we have a small number of devices, IoT devices that are using this frequency is sufficient. What will happen in the future when we got more and more devices that are using the frequencies? LoRa is going to interfere with Sigfox, interfere with Wi-Fi, interfere with a lot of proprietary systems. So what do you see in the future? What will happen to a Spectrum?
Very good. Perhaps should start with Eric. Sorry, Alan. Yeah, try again. Jonathan.
Hi, maybe I'll answer from a Sigfox standpoint. They are in Asia, all right. We are considered Sigfox Zone 4. There are 4 zones of frequency in the world. So we try to limit as little as possible so that it's for global roaming. Within Asia, it's largely Zone 4, and Singapore is in 920 to 922 megahertz. All right, so there's a free ISM band over there. Right now, it's very free. We're running well, no interference, and the result has been very good, extremely good, much better than I thought. But of course, you asked me, what if there are zillion devices out there, would there be interference? All right, I won't call myself a network RF expert, but based on what I understand, it's actually very hard to do that, all right? Because why? Sigfox is operating on the ultra narrow band. In other words, it takes very, very little space within, if you draw the diagrams. So when I send out a message and press the buttons, it will send out 3 messages within this band of frequency that's allocated to us, all right? And in 3 hopping within frequency hopping, so it just randomly pick and send out 3. So in other words, you have 3 times the chance to get it through. And so the chance, yes, will there be a chance of collision? Possible, but I think it is rare. Because why? It takes very, very little, so it keeps hopping around. Then the other thing is, if you ask me, okay, let me put an example. We have an operator. We also operating in Taiwan. So Taiwan, there are actually quite a few LoRa implementation, quite big ones like electronic toll gates and so forth. The problem with that is that because LoRa is a spread spectrum, so when you have a few of them together, you have a higher chance of interfering with each other. So in a way, in Taiwan, the interference and the actual expected bandwidth on LoRa down there is not as good as it's supposed to be because they were out. But if you ask me, what happened in Sigfox? You won't get Sigfox network interfering with Sigfox because there's only one operator. All right, so it is controlled by a back end. So there's no risk of conflicting Sigfox committing each other. But of course, what if Sigfox and LoRa come together? You think about it, LoRa is a spectrum, Sigfox is ultra narrow band, all right? So when you have this interfering with this, what will happen? Who will interfere with whom? All right, you need to think about it. All right. So in my opinion,
they both cohabit. I mean, the spread spectrum's moving the transmissions around to get around the Sigfox signal. But yes, I think perhaps another counterpoint.
I think, whilst that's the Sigfox point of view, I think to actually answer your question, frequency or spectrum exhaustion inside the ISM bands is a major concern to any low-power radio provider that's non-frequency compliant. So Sigfox might say they use ultra narrowband, LoRa might have spreading factors and might be able to jump around between frequencies. But fundamentally, that band is open for anyone to use within a particular broadcast frequency. So what is the future for unlicensed free spectrum allocation is a very good question. What I think is probably going to have to happen on a more regulatory point of view is there will probably need to begin to be regulatory allocation for low-power radio networks. Otherwise, we are just going to keep contributing to a point where there cannot be any more low-power radio devices existing in these bands. And it's not just low-power radio. I mean, it's the ISM bands, industrial, scientific, and medical. So that encompasses anything which is able to send in a small transmitter output, and that changes depending on which country you're in. So I know in the US, a company called Link Labs that works very highly in LoRa, they've published maps and they show the major US cities. And because the US doesn't have power restrictions on, or has very limited power restrictions on what it can do in ISM, they're already flooded. And LoRa and Sigfox struggle. And you see LoRa devices there use the highest spreading factor possible, which means it will try and send out over as much of its channel as it can to try and get it through. And even then it's struggling. So that's where, you know, the 3GPP specifications do have a little bit of an edge because they are in licensed frequency bands. So I'm not 100% sure exactly how we end up solving that question without essentially making these licensable frequencies.
Very good. Any other comments? Professor Yang Yang?
Yeah, I think this is a critical question about the development of IoT application. I agree that for unlicensed band, it will be a challenge to avoid any interference. So that's why NB-IoT is so preferred by the telecom industry. But on the other side, we do see many different vertical industry leaders. They have their own spectrum, and they want to use IoT solutions. They don't care if it's LoRa or Sigfox or NB-IoT. For example, we are working with a broadcasting company in Shanghai. They have their own spectrum. So they have a lot of free spectrum. So they want to occupy this free spectrum, but they want us to develop a specific air interface using the existing technology for them. Another company in the power industry in China, they have their own spectrum in 230 megahertz. So it's another customized design requirements. I think for those kind of industry, we still have a lot of opportunities, and they are very powerful. They are very rich. They can pay for the bill, and I think that's a good opportunity for us as well. Unlicensed spectrum is the initial, I think, to engage general public, but the profit may be in other vertical applications. That's my opinion.
Very good, very good. One last comment?
No, I pretty much echo what they said. You know, I also feel that, you know, we're at the early stage, so this is okay, and we're all learning at the stage. But up to a certain point, if it gets really crowded, and that's actually good for the industry, we might have to make some considerations whether it's licensed or not. So,
very good. We've got 5 minutes left. Are there any other questions from the floor? Gentleman at the back, state your name.
Yeah, my name is Kev. I work for a company called Lend-Lease. We're a property and infrastructure developer. So we have many buildings throughout Singapore and the world. We're very interested in this new network, you know, for the IoT, and we are looking to connect many building elements, building aspects of the building online. But the question that often gets asked at the end was always about cybersecurity. You know, we're starting to hear many more breaches than there are before the internet, right? So, what is your perspective on how we can secure ourselves as we sort of move into this new world of connectedness? What can we do to best protect ourselves? Thanks.
Very good.
Again, that's a very good question, and something that we've been spending quite a lot of time looking at. So one of the interesting challenges comes from segregating the security aspects and the security concerns you have from the network security. So when you start to look at it, there's only so much you can secure a network before you essentially have to assume that it's an open public network and any of your data can be seen. You look at GSM, you know, 15 years ago, everyone was like, oh, that's unhackable. Now you can do it with a Raspberry Pi and a reasonably generated antenna on it. So we've been doing a lot of work in this field. Specifically, there's a big French defense company called OpenFog, and they provide what's known as a secure element in their mTrust platform. And basically, it's the same technology as what's used in your credit card. And you can build that into your device, either as a software element in a secure area on your chip, or as an individual actually soldered on device. And what that can do is that can essentially do a challenge response encryption all the way through the network layer to the cloud. And then you can decrypt that in your application. So you don't actually have to worry about your communications layer at all. So, you know, whatever security Sigfox has, whatever security LoRa has, whatever security LTE, 3G, whatever has in it, is enough to encrypt your transport layer, but it doesn't encrypt your data. And the key thing that you have to worry about as the service provider or anyone who's going in and actually putting this publicly identifiable or personal identifiable information is the security needs to lie with either the application or the device, and ideally both. Otherwise, you're putting your trust in a network provider you don't always know has A, your best interest at heart, or B, an adequate security model which will allow you to secure all your devices down, and you don't know that a security model on the network will actually maintain as computers get faster and new methodologies come out for breaking encryption. So we're very much focused at the moment at looking at how do we provide a service and a solution that even we as a network provider cannot see what that data is passing over our network. So one of the key things we do is, we do everything privately. When you talked about cloud providers having private links, I have links into Amazon, I have links into Azure, I have links into IBM. We do all that privately, but that's still not enough. You know, that reduces the chance of you having a data breach, but it doesn't solve it. So we're very much looking at using secure, dedicated elements in the device and the application stack so that the transit provider never knows what's occurring.
Very good. Jonathan, one last comment?
Yeah, you're interested in new networks. Okay, let me explain in a more simpler term. If you look at the entire end-to-end, from the device to the base station, is Sigfox or LoRa, whatever. So that's a special unique thing. From the base station all the way to your application is standard TCP/IP. All right, so I wouldn't address this because a lot has been said on cybersecurity on the TCP/IP world. So whatever encryption is put in there, we have AES encryption in there. Whatever additional you want to put, you can put in. Whatever difficulties or whatever risk is a standard thing across everybody else. So it is probably, I would say, the point of discussion today. That's a whole new thing. All right, it's the same for everybody else. I'll just talk about the unique one portion from the device to the base station, because that's uniquely Sigfox. Everything else backwards is just TCP/IP. The good and bad of it, everybody is the same boat. All right, and that is the Sigfox, the network, it is an RF network. Can I ask, how often do you hear an RF network being hacked? When is the last time? Nothing is unhackable, nothing. But the thing is, it's not common. Your car key, you press the car key, you have a BMW or Lamborghini, you press it. Yeah, it can be hacked, but very, very rare. Because that's on RF network. When you make a phone call, or when you serve your on an iPhone, from your phone to the base station is RF. From base station onwards, backwards is TCP/IP. Where do people hack? People don't hack in between the phone and the base station. They hack from the base station backwards, the TCP/IP. The danger is always in TCP/IP. It's not in the RF. Because why? RF is very, very hard to hack. On top of it, let me tell you one more thing, even more crazy. If you were to go in the war zone, all right, Afghanistan or whatever it may be, I was in the satellite industry before. You look at, in the war zone, people point radio, satellite dish, point up to the space, and that's where they transmit their war plans. All right, that is on RF, but it's all out in open. Anybody can put it, so theoretically it's all out in open, right? But is it hackable? Not very hackable, very, very, very tough, because it's in RF, it's not TCP/IP. So the Sigfox network, or LoRa network, or whatever it is, or even the GSM network, between your device to the base station, very, 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 very hard to hack. Very few people have done it before, and very few people are trying it. So as simple as a car key, to the GSM phone, to a satellite dish, it's the same. It's very, very hard, all right? So, of course, sometimes people mix up. For example, recently there's a denial of service things on CCTV camera that create a lot of hacking. You must know, that, strictly speaking, yeah, it's IoT, but if you look at the CCTV camera, what are they? They are just very low-end PC in a sense.
Well, it had the default passwords.
They have default password.
They weren't changing the password.
And there are like millions of CCTV out there, and they have no antivirus program there. So actually, it is a disaster waiting to happen. And people use it for denial of service. But can you do that in Sigfox chip? Very difficult. Why? Sigfox is sending on 12 bytes You sleep most of the time. You can't do that. Very, very. So that kind of denial service is not possible on tiny little IoT devices.
Very good.
All right, I know we have no time.
We are, my sign in front has gone red and a negative sign, which is probably even worse. I think so key takeaways are, clearly there's a lot of opportunity, there's a variety of different application scenarios, which means there's path diversity in terms of building a viable business model. Some issues over security, but nothing major. I think things will evolve over time. Spectrum is to be addressed, but maybe the regulators will step in when they see the volume of traffic really build. And I think on that note, I'd like if you just give a warm hand to my colleagues on the panel. Thank you very much.